You ever wonder why a bubble is always a perfect sphere? Or why when you throw a ball, it always makes that same graceful arc? Well, it's not random. There's actually a hidden logic, kind of like a secret set of rules that shapes our world. And today, we're going to pull back the curtain and see what those rules are.
So, let's kick things off with a little brain teaser. Think about a shape we all know, a circle. Now, how would you describe one to somebody without actually using the word circle? Go on, give it a thought. It's actually a lot trickier than it sounds.
The secret isn't to describe what it looks like, but how you draw it. Imagine you stick a pin in a piece of paper. That's your fixed point. Now you take a pencil and you say, okay, this pencil has to stay exactly 3 inches away from that pin no matter where it moves. What kind of path does it trace?
Well, that pencil is going to draw a perfect circle. It literally has no other choice. Its path is totally dictated by that one simple condition. And this idea that a specific rule can create a specific shape is honestly one of the most powerful concepts in all of geometry.
Now, this rule isn't just some casual idea. It has a real official name in math, and it is the key to, well, pretty much everything we're talking about today. The name for it is a locus.
So what in the world is a locus? It's really simple when you break it down. It's just the collection of all the possible points and only those points that follow a certain rule. For our circle, the locus was all the points that are exactly 3 inches from the center. It's the shape you get when you follow a rule.
You know, an even better way to think about it is that a locus is like the recipe for a shape. It's the set of instructions. And if you follow that recipe perfectly, you are guaranteed to bake the same exact cake, or in this case, draw the same exact shape every single time.
And the cool part is, you don't need some giant, complicated cookbook. In classical geometry, there are really just 5 of these fundamental recipes, or loci, that are the building blocks for almost everything. Let's check them out.
All right, rule number 1. Imagine you have 2 fixed points. Let's call them A and B. Now, the rule is this. Any point you draw has to be the exact same distance from point A as it is from point B.
So if you start plotting out all the points that follow that rule, you might be surprised. You don't get a curve. You get a perfectly straight line that slices right down the middle between A and B at a perfect 90-degree angle. We call that the perpendicular bisector.
Okay, you ready for rule number 2? Here's the condition. All points have to be a specific constant distance away from one single fixed point. That should sound pretty familiar by now, right?
Yep, you guessed it. That's our circle. It's the locus we started this whole thing with. The fixed point becomes the center, and that fixed distance, that's the radius. Such a simple rule for such an elegant shape.
The other 3 basic loci follow that same kind of logic. Like, if your rule is stay the same distance from 2 parallel lines, what do you get? A new parallel line running right down the middle. Or what if the rule is stay a fixed distance away from a single line? That gives you 2 parallel lines, one on each side. And finally, if you stay equidistant from 2 lines that cross each other, you end up drawing 2 new lines that perfectly split those angles in half.
So these rules are really cool visually, but where they get super powerful is when we take them out of this abstract space and put them on a map. You know, the good old XY coordinate grid from math class. This lets us translate the geometric recipe into a precise algebraic equation.
And this really shows you what I mean. The locus, the rule, that's like the blueprint for the shape. It tells you how to construct it visually. But the equation, that's its street address. It's a precise formula that tells you exactly where that shape lives on the grid. They're just 2 different languages describing the exact same thing.
Okay, so we've seen that simple rules give us familiar shapes like lines and circles, but what happens when we make the rule just a little bit weirder? What if the condition gets a bit more complex?
Let's try a really strange one. What if the rule was that a point has to be the exact same distance away from 2 totally different things at once? It has to be equidistant from a single fixed point and a fixed straight line. I mean, how would that even work? How can you be the same distance from a dot and a line simultaneously?
Well, we can actually figure this out just by plotting it out. There's one easy point right away, the one that's exactly halfway between the point and the line. But then it gets interesting. As you move to the side, the distance to the line is always straight down, right? But the distance to the point is now at an angle. So if we just carefully find all the spots where those 2 distances match up perfectly, a very cool, very unexpected shape starts to emerge from the dots.
And what you get is not a line. It's not a circle. It's a perfect parabola.
That beautiful, sweeping curve you see in the arc of a thrown football or the shape of a satellite dish. It's born from this one, single, kind of strange rule. Pretty amazing.
So let's just take a step back and think about what this all means. Why is this idea of a locus so important? What's the big takeaway here?
Well, it shows us that the shapes we see every day aren't just random. They aren't just there by accident. They are the logical, inevitable results of simple, elegant rules. It's like there's a hidden grammar to the universe, and these shapes are the words it's speaking.
You could almost say that the locus is the engine that creates the entire geometric world. It's the mechanism that turns a simple condition, an idea, into a physical form you can see and measure. It's really like the DNA of a shape.
And that leaves us with this one last, really fascinating thought. If simple rules can give us things as fundamental as lines, circles, and parabolas, what other incredible, complex, maybe even beautiful patterns are just sitting out there, waiting to be discovered, hiding inside new rules that we just haven't even thought of yet?